All right, so number 40. Use a graph of the function to approximate the solution of the equation in the interval negative 2 pi, 2 pi. So this one is the secant of x equals minus pi over 2. So, now this document should be posted on Edline. So, first thing I do is I graph the secant of x on the interval from negative 2 pi to 2 pi. And so how do I do that? Well, I graph the cosine of x from negative 2 pi to 2 pi, and that's in black. And so then I graph the secant, which has the graph, and that's in red. So it has the asymptotes where the cosine equals 0, and it has the relative maxima where the cosine has its maximums and minimums. So then I approximate negative square root of 2, which is like a 1.4, and I draw the dashed line, and that dashed line is right here. Okay? And now I happen to know that the cosine of x is the square root of 2 over 2. So, and we're supposed to find this exactly, okay? Or it can be negative square root of 2. That's like a cosine of 45 degrees. And the cosine of 135 is negative root 2 over 2. Now, here we have the graph, so I know that these four intersection points of square root of 2. Now, okay, now let's talk about square root of 2. Let me get my thing here. So, if you take the cosine equals the square root of 2 over 2, let's say negative, then the secant equals 2 over the square root of 2, which equals the square root of 2. 2 times the square root of 2 over 2, the 2's cancel. And so the secant of 45 degrees simply equals the square root of 2. Now this is negative. So where is it going to be negative? Well, let's look at it here. This is going to be, this is negative 2 pi, okay? So this is negative pi, and this is negative 1/4 pi. So negative 5/4 pi, and this is pi over 2, and then so this intersection here of the secant and negative square root of 2 is between negative pi and negative pi over 2, so that's negative 3/4 pi. Whereas this intersection is between negative pi and negative 3/2 pi, so that's negative 5/4. Okay, now there's no more intersections. Here the secant is positive up here. Until we get to between pi over 2 and pi, so that's 3/4 pi. And then pi and 3/2 pi, so that's 5/4 pi. 5/4 pi. So the four intersections are negative 5/4 pi, negative 3/4 pi, 3/4 pi, and 5/4 pi. But the key to figuring this out is knowing that the reciprocal of square root of 2 over 2 is the square root of 2, and recognizing that the reference angle for all four of these is going to be 45 degrees. So this is some multiple of 45 degrees, or pi over 4. Okay, so the next one you want to know is 55. Okay. So let's look at 55. What does 55 want to know? Okay, this is the damping functions. Okay, so use a graphing utility to graph the function and the damping factor of the function in the same viewing window. Then analyze the graph of the function using the method in example 6. So we'll talk about that. So first, let's look at the solution. Okay, so here's the graph. So let's see if I have, let's get my calculator up here. And do I have, here's 55. Okay, no I don't. All right, so here's how we graph it. So we'll do e raised to the power of negative x, and that's this graph right here. Okay, right here. And then negative e to the negative x, and that's this graph right here. Okay, and then e raised to the power of negative x times the cosine of x, and that's this graph right here. Okay. Now, e to the negative x times the cosine of x has to be less than or equal to e to the negative x and greater than or equal to negative e to the negative x. It's always going to be between these two functions. And you can sort of think of e to the negative x plus and minus as the amplitude. But it's a weird kind of amplitude because it's not a straight line. But it's just like the amplitude in that it sets the vertical maxes and mins for the function. Now you can't see much of the function, but as it goes down, it's going to touch down here and so on. Okay. Now, so that's the first thing here. Okay. Now, where does plus or minus e to the negative x touches this function, e to the negative x times the cosine of x, at, well, where are they going to touch each other? At the maxes, at x equals n times pi. Okay, because pi is where the maxes are and where the mins are. What does that mean? Well, the period is 2 pi, right? Let's think about the period. Let's just draw a quick picture of the cosine here. Let's say this is pi and 2 pi. Okay, so it starts here, and it goes down to the min, and then back to the max. So here, and here, which is 0 pi, 1 pi, and 2 pi, these are the points as the cosine wave goes on, negative direction and positive direction. It's at these points, at the multiples of pi, that the graph is going to touch e to the negative e to the negative x. This is e to the negative x here, and negative e to the negative x here. Okay, and so wherever the cosine has a max or a min point, it's going to be touching. So what's another way to draw this? Let me get some more space here. Let's do this. Let's insert a page. Let's put it in right here. Okay. No, I didn't want to do it. I wanted it right above 50. Let's put it, I wanted it right here. Let's try this. Insert a new page. Maybe it'll come in here. Okay. So let's just try to draw the picture a little bit. Let's do this. Okay. So here's the two damping graphs. And just think of the cosine touching here, and then here, and then here. Now you see, it's going to touch e to the negative x wherever it's at a max or a min. You can't really see this on a calculator. Now I'm just drawing it all goofy. But if you could scope down to it, that's what it would look like. If we had a better graphing utility, that's what we would see. And so you can see that this is going to be some multiple of n pi, n minus 1, n minus 1 pi, etc. So this is some multiple of pi. This is, okay, each one of these points is some multiple of pi, as long as we're thinking about y equals the cosine of x being graphed. Okay? All right, so where were we? So that's, okay. Now, e to the negative x times the cosine of x has x-intercepts at cosine of x equals 0. Okay, well, in other words, it's going to have x-intercepts where it always does. okay, at pi over 2. And so now let's just draw a regular cosine again. We can draw a little better. Okay, 1, 2, 3, 4. Okay, so let's say here, here. I'm sorry, here, here, here. So here's our cosine. Okay, so it starts out the max, goes down here. So where are the x-intercepts? So here's 0 pi, and here's 1 pi, and here's 2 pi. Well, here's pi over 2 x-intercept, and 3/2 pi x-intercept. So at any multiples of pi over 2, you have an x-intercept. It does, and see, you can see x-intercept, x-intercept, x-intercept. These are all multiples of pi over 2. So the only thing that's different, it's a cosine function, but even it's just as it always did. It's just that it's being squeezed between e to the negative x and negative e to the negative x. That's all. That's it. Everything else is the same. It's a pretty straightforward idea, but it makes for it's just for a much more interesting function and just a lot more interesting to look at. Okay, so let's see. We answered everything in 55. Yeah, we talked about the upper and lower limits of e to the negative x times cosine of x. We talked about where e to the negative x cosine of x touches plus or minus e to the negative x. And we talked about the x-intercepts for e to the negative x cosine of x. Notice that the x-intercepts are completely unaffected by e to the negative x. It's just simply the x-intercepts that cosine of x would always have. Okay. And then finally, 64. Let's talk about 64. Let's look at what the question is. Oh yes, a television camera's on a reviewing platform. Okay, so here it is. It's 36 meters straight away, perpendicular to the street. Okay, and so we consider the distance from the parade, the center of the parade. We call this dot here. Okay, this is the center of the parade here. Okay, and then d is the distance away. Now, write the distance d from the camera as a function of angle x, and then graph the function over the interval of negative pi over 2. X is less than pi over 2. Okay, so let's do that. So let's go back to our thing here. I don't know if I made the graph. We'll see. Okay, so 64. Here's 64. Okay. So 36. Yeah, well, I did make the graph. I did it by hand, but we'll do it on the graphing calculator as well. So the cosine of x equals 36 over d. Cosine, here's theta. Okay, cosine of x equals adjacent over hypotenuse, 36 over d. Okay. All right, we in agreement on that? Okay. All right. So d equals 36 over the cosine of x. Or d equals 36 times the secant of x. Is this what? Wait a second. Let me make sure I'm answering the question. Here. Write the distance d as a function of angle x. Yeah. Yeah, d equals 36 times the secant of x. Okay, I'm doing it as a secant because I think they want us to do it as the secant. Okay, now we're going to consider, they want us to do the period from, negative pi over 2 to pi over 2. Okay, so what does the secant look like? Well, here's negative pi over 2 to pi over 2. It looks just like this. And 36 is the amplitude, okay? So the relative min is 36, right? And let's look at the picture again. And you can see this is the minimum distance that the camera is going to be from the parade. It's 36 meters. At all other distances, it's, at all other points, it's going to be more than 36. And as the parade, imagine the parade walking away from the camera. Okay? So the parade's going this way. Well, if the parade went far enough, the distance between the camera and the parade would be infinite. Okay? It's asymptotic, which is how the graph looks. Okay? Imagine the camera going, there's the parade going this way. Okay? And it's approaching infinity and approaching infinity this way. And as the parade comes towards the center, its distance from the camera, if you can think of the cameras here, is 36 feet. So let's put this on the calculator just for the heck of it, so you can think about doing this. Did I do it on the calculator? I wonder if I did 64. Let's see. Yeah, there's 64 right there. No, I don't. Is that 64? No, that's not 64. Is it? No, that's not 60. That's not, I don't know what that is. File. Come on, that's 65. Here's 64 right there. That's not, I don't know what the heck that is. I must have saved the wrong thing. Okay, anyway, let's just clear this out. So let's clear. That's another problem. Okay, so we're going to do 36. Now notice here, here's the key thing to note. Okay, we're not going to do one for the cosecant, or for the secant. We're going to do 36 times 1 divided by the cosine of x. Okay, so no, we're not doing 1 over 36 or whatever. Okay, like it is here. This is what we're doing right here. Okay. All right. I could just do 36 divided by the cosine of x. I don't know why I did times 1 over whatever. Okay, now let's play with the window. Okay, we want the minimum to be negative pi over 2. And we want the max to be pi over 2. Okay, and then let's make the scale pi over 8, 1/8 of a pi. Why not? Okay, pi divided by 8. What the heck? Okay, now the max should be, well, let's see. Let's make it, I don't know, 50, I guess. Let's make the max. Let's make the mins 0. And let's make the max 50. And we'll make the scale 5. Let's see what this looks like. Okay, there we go. That's it. All right. So it's from here to here is 36. So, yeah, and let's just verify that second calc value when x equals 0, y equals 36. Okay, so there's the graph. We could make y bigger to see more, but anyway, that's what it looks like. Okay, so that's those 3 problems, 40, 55, and 64.